Hello everybody, welcome back. Let's continue with the example that we started last class. Example 1.4.1, we're asked to show that the following subset are linearly dependent directly from the definition. So our definition tells us that to show that a set is linearly dependent, I need to be able to write one of the elements as a linear combination of the other. For the first example, part A, it wasn't too bad. The first one I took and I tried to write as a linear combination worked. And so I could tell that S was linearly dependent. All right, let's attack B. Let's go the same way. I'm going to try to write 1, 1 minus 5, 1 as a linear combination of the 3 orange vector. All right, so when I set up my system, I'm going to put my 3 building blocks, the 3 vectors that I'm using to build the other one. I'm going to put them first, and then I'm going to put my red vector that I'm trying to build, and I'm going to put that one as the constants. All right, so let me reduce for you again. Here's what I got. I got minus 2, 3, 0, 0, 0, 0, 1, 0. It's inconsistent. So 1, 1 minus 5, 1 isn't a linear combination of the 3 orange vector. All right, that's kind of disappointing, but I chose 1, 1 minus 5, 1. I didn't need to choose that one. So maybe one of the other ones would work. So let us try a different one. So let me try to write 4, 3, 5 minus 3 as a linear combination of the other 3 vectors. All right, so I still have the first 2 building blocks the same. I'm going to put 4, 3, 5 minus 3 as the columns this time. So I'm switching the third and the fourth column. And when I reduce, if I do exactly the same row operation that I did over here, if I do exactly the same row operation, I'll end up with almost the same matrix, but of course the last 2 columns are switched. All right, so this is from above. Don't need to re-reduce it. I know how it reduces, and this one is consistent. So 4, 3, 5 minus 3 is a linear combination of the other ones. In fact, let me write it. 4, 3, 5 minus 3 is minus 2 times 1, 0, minus 1, 3, plus 3 times 2, 1, 1, 1, 1, and plus 0 times 1, 1, minus 5, minus 3. All right, so yes, S is linearly dependent. All right, so we had to choose one of the 4 vectors here at the start to try to rate it as a linear combination of the other ones. Out of the 4, 3 would have worked, right? This one would have worked, this one would have worked, and this one would have worked. As long as there's no 0, then you can actually isolate it and it's going to work. So out of those 4, only the last one would not have worked. But it's still a hassle to have to pick one. It's still a hassle that the definition is not symmetrical in the elements of V1, V2, V3, V4, that you have to pick one to make it special. And so what we'll do the next next video is we'll prove that there is a way of making it symmetrical. We'll use a definition that's closer to what we did in linear 1.